So tlo edit grade 12. Grade 12 and only two things, which is the compound and double angles. So this is the basics, but even the grade 10, 11, they can watch the video, especially on the beginning, up until you get to the double angle and the compound angle. Right, as you can see, we have the introduction here of the trigonometry. So we're going to deal with triangles. One tri means 3, and then we're going to deal with the measure of the sides and angles. So the triangles, what are we doing in triangles? What are measure the angles and or together with the sides. So the vergra kamano or the relationship between the angles and the sides, or the amount within one triangle. So this the special triangle is the right angle triangle as mentioned here. With respect to the given angles inside it. Now, for having a renal triangle, as it is, let's look at the first one on the left. So we can call it triangle 1, and this will be 2. Now, on the triangle 1, there is a 90-degree angle here. Now, this 90-degree angle, oral side level learning leona. Roaring, I set level this side. So side leveling or opposite. So opposite here, roaring opposite the side even opposite to 90. Then that side always right angle triangle from we call it hypotenuse. Then a hypotenuse again side triangle. You see, there is the longest side of a triangle. Now, our feature, or we have the other two angles in the triangle. Now, the angles is dealing the horizontal line and the other transversal line any other angle. So measure the angle from that, or the angle it will delegate the two lines. So our angle our angle here is given as theta here. Our angle, this angle opposite to this side. Now side being opposite to yona, is opposite to theta. That's why I mentioned is opposite to theta. It's not just opposite to angle theta. So given a triangle which is empty, so you cannot say this is always the opposite, but the hypotenuse is always opposite to 90. So we start by identifying the hypotenuse. Then there is other side here next to the this side next to the angle here. So this side adjacent. Side this angle theta, then we call it the adjacent side of what? Of that angle theta. So let's observe the difference here between the two triangles, because we have this one. Now, in the other triangle here, let's observe that we have our 90 degrees here, and this 90 is opposite to this side again. So opposite to this side is the side opposite to 90. We hypotenuse. So our hypotenuse I change it to game because it will 90. So that depends on triangle. Then Now look at our angle. Now is given theta up there. So what will theta go dimukwa? I mean, this side. Look at this side. I mean, this side. I sale the opposite. Also, like a triangle now one. So it's now changed to be adjacent. Why is it adjacent? Because eventually this side kiloring angle theta idichudi mayo now. So that's why it's called the adjacent now. Then this other side, this one is now called the opposite to what? To that angle, opposite to angle to theta. Now this one is now called the opposite to angle theta. So around if you feel a triangle, what's no this the two sides, maybe are the two sides, what's this side or this side is opposite or adjacent. Can tell what's about angle if so the angle pele or cave. So in this case angle jever shumishangarna rena kijona alpha. So shumisha these three angles. Shumisha theta, shumisha alpha, and then shumisha angle beta. So they, you know what the Greek names maraj or Rishumisha over the unknown angles. So or theta image is certain magnitude or angle. Or you can over 10, you can over 15 degrees, 30 degrees, a number. Let alpha image join. So rather yes, I go via that angle, the name, the number. Or the substitute got this 3, one of them or 2 inside the triangle. Right, so requiring are no adjacent or opposite without the reference. So the more point down reference ke adjacent inside the triangle. Ke opposite then that's when you can identify the opposite and the adjacent of that. Right, let's look at the other parts of the triangle. Now let's call this one 3. Let's call this one 4. Right, or on this triangle. Now we're still having the same information. This is our 90. This is our 90 opposite. This is 90, and this 90 is opposite to AC. Now, erroring in this case, AC will be our hypotenuse. And then now R level our any other angles. But the angle is on erroring the corner ever feeling on this corner here or angle A, and then this corner here or angle C, then this corner here, the other one the hypotenuse or the angle B. So running armal angle or more inside this one, we'll just call it an angle A, and then that will be the angle inside here. So we use that arrow, a letter, a capital letter, to show that is an angle. Right, and then from there, let's see. Or now, if relativity A, position A, which one will be the opposite? So of course the opposite to this one will be this side. So this side will be the opposite. And then A in this case, irujudima side alpha, irujudima the side here AB. Now meaning the AB will be the adjacent. So this will be the adjacent side. Then now we have our triangle. Now looking at this, the triangle number 4. Or now, before we get to number 4, let's look at that triangle again, number 3. If we are looking at angle C is here. Now, if we're looking at angle C, this angle C is having a opposite side, which is that one, which is AB. Now, according to AB, then this, according to angle C, or AB is our opposite. AB is our opposite side. But already angle C is judima BC. Already BC are again the adjacent side. So wondering what the adjacent and opposite, they can interchange on each other. So this side can be both. Let me get another color. So this side can be both opposite and adjacent. This can be adjacent and opposite, but depending on where you are standing, on the reference, on it depends on the angle or angle out the. So this is what we have for the opposite and adjacent. Now let's have the triangle 4. Now on triangle 4, we still have 90 degrees there, and then is opposite to this side. So it means QR is our longest side, which is the hypotenuse of this triangle. And then from there we have angle Q. Now angle Q here. Now on this angle Q, what we have, our angle Q is going to give us the opposite side with this one. So our PR, this one, the side is the opposite. So we can have our opposite here side against angle Q, and then it means this one at the top here is the adjacent, which is PQ. So PQ is the adjacent side. So if we have angle R, so our angle R here, so if we have angle R, so angle R here, so this angle R is opposite to that side, which is PQ. Then it means PQ in this case, it will be the opposite or to angle R. Then this other side, which is PR, will be now the adjacent. This will be the adjacent side. Then that's what we can have for the triangle. So we must start by identifying the opposite, the hypotenuse side. Then the two can interchange depending on the position. So once we determine 90, then we know the hypotenuse side. So down here are the notes trying to explain whatever I was explaining there. Right, let's get to the definition of trig ratios. Now in our definition of trig ratios here, now we define the trig functions. So when I say trig ratios, you know the ratio will be maybe A over B. Now once we have A over B, we have a fraction. So normally they know a ratio as A is to B, but we know this can also be written as this one, A over B. So once we have the two, we have the ratio 1 of the 2. But here when I say trig ratios, trigonometric ratios, then we use their definitions of their functions against the ratio. So now in other words, we're giving us a relationship or gamma angles and the sides in a triangle. in one triangle. So let's get the relationship defining the angles and the sides. So probably be careful when doing this the definition. So number one, we have the triangle here. This triangle is a right angle triangle. So again, right angle triangle, this will be our hypotenuse, and then now we're given angle theta here. So if theta is here, now we consider one angle at a time. A real angle angle the opposite then the adjacent, because the hypotenuse is 90 degrees. So this side now will be the opposite to this theta, which is angle F, and this side will be the adjacent. So this side will be the adjacent side of this theta. Or opposite adjacent, and then the sides, and then refer in terms of ratio. So now they're saying the sine of theta, the sine of the angle theta here. Or this side, if you were saying ratio, remember I said A over B. So it shows that one angle, so because A is a side, B is another side, so that ratio is the sides, and the definition is from the angle, then you define a side. So the first period here, they are saying sine theta equals to the opposite side to theta over the hypotenuse. Now define our hypotenuse here is this one. So, and the opposite is also defined as this one. So what is the opposite? The side, remember this opposite and adjacent are the sides related to the angle, the position of the angle. So that's why they're saying is DE, the opposite is DE, and the hypotenuse is FD. So it's written in this way. So that the whole of sine of theta, it represents the two sides, which is the opposite and hypotenuse. And then always, it means the definition of sine, the definition of sine, let's write it here. Now the definition of sine is sine like this. So it is always opposite over hypotenuse. So this is the trig function, the side and another side. So this is the first side, and this is the second side. That is related to this one is giving us triggering the angle. This sine is trigger the angle, the relationship with this side opposite of that angle and the hypotenuse of that angle. So that's what we have for the sine. Right, now let's get to the other one. So let's get the cos, number 2. Now cos of theta, which is even cos of that angle, they are saying is the adjacent side to theta over hypotenuse. Now the adjacent side is regulatory EF over DF. So it's written like this one here. So when we're going to write this, I will simply write cos of theta equals to, now I said the adjacent is EF over the hypotenuse is DF. Then remember this EF and DF that will represent the numerator. or the length of this side, and then the replace divided into which ratio. So it's given in that form there. Right, let's get to the tan. Now tan of theta of the position then will be opposite over adjacent. So running the opposite over adjacent will be the opposite still find on that. So because our theta is not changing the position, always be there and have the opposite like that. So it's defined like DE over it's defined by DE over EF. So that's why we have the opposite over the adjacent. So that is the definition of the tan of theta, where theta is given in that position. Right, the other ones, these are the inverse of each one. So meaning that cosec is the inverse of sine theta. So look at what is happening. Here's DE over DF. Here's DF over DE. So they just inverted. Sine. So meaning that the reciprocal of sine theta is equals to the cosec theta. So meaning the cosec of theta, here they are trying to explain the cosec of theta is 1 over sine theta. And then cos theta, it will be the inverse of this sec theta. So they just inverted this, or find the reciprocal of this one. So cot will be for tan theta. So as long as you know the original ones, normally in caps we are covered only the first three: sine theta, cos theta, tan theta. These ones, they are eliminated for now. So let's not have headache on these ones. So maybe they are studied in earlier in grade 10, but the caps said we must leave them out. Right, now that's the definition we have. Now before we get to the next page, so if we have our other angle there as alpha, let's try to squeeze it there, alpha, which is this angle. Now look at that angle. Looking at that angle, around the opposite and the adjacent, they will change. So the change now we are going to have this situation here. Now this was the adjacent. So let's do it like this. Now this was the adjacent. Now it becomes the opposite of that alpha, and this will become the adjacent of that side. Or let's do this. So this will become the adjacent of this alpha. Now if we're writing the trig ratios, they're going to change. Now it means the sine of alpha, looking at the reference of the angle, now will be, now sine we said is opposite over hypotenuse. The opposite is now the EF, which is the written people. So we're going to say EF over, and then what do we have there? It means we'll have the hypotenuse is still the same, it's not changing. We'll have DF. That would be for that case. Then if we have cos theta, cos alpha, then the alpha, then cos we said is adjacent. What is the adjacent? Is DE over hypotenuse is DF. Then the last one, having tan alpha. So the tan of alpha will be the opposite in this case of alpha. EF over the adjacent. Then our adjacent in this case is DE. Then we can have this situation in one triangle. So having 90, alpha and theta. So depending on which angle they are pointing, when they want the relationship with their side, then that's when you can know whether which one is opposite, which side is opposite against which angle. So that would be the relationship between the side and the angle. That is now the definitions of the trig ratios. The angle, the function of angle with the sides. So we change the angle with the sides. So they must point the sides. The angle must point the sides. Then I replace a cos of theta, replace the ratio of the sides only. Right, let's get to another revision of Pythagoras theorem, applying those ones that we had there. So that's revision grade 8, 9, 10 work. We use the Pythagoras theorem. Now the same definition of Pythagoras. The Pythagoras theorem is only used in a right-angled triangle. So you must note this. So this is only identified in a right-angled triangle. So if it's not right-angled triangle, then it will not work. How do you know right-angled triangle? Our right-angled triangle will always have 90 here inside it. Or triangle are not global 90 degrees angle. So if I buy 90, then they'll put this box at the corner. Then wherever available box that angle is 90. Right, and then the square of the hypotenuse is equals to the sum of the squares in the remaining two sides of the triangle. So now we'll say, in other words, if we write the weight formula, we remember if we have our triangle, if we write the weight formula, we'll say the hypotenuse squared, because I say the square of the hypotenuse is equals to the sum of the remaining. What are the remaining sides? We are remaining with the opposite side, then we must square that opposite side, and then the sum equals to the sum of the square of the remaining two sides. Then we must square them, and then we add the squares. So running and the adjacent squared. So this must also be like this. So this will be the formula of the Pythagoras, where you have hypotenuse squared equals to opposite squared plus the adjacent squared. So that will be the weight equation for Pythagoras theorem. Right, let's get example 1. So already given example in the diagram below, triangle ABC. So triangle ABC corner down. So we have corner number 1, which is A, corner number 2 B, corner number 3 C here. So it's being set with their corners. So we set angle B. Let's do like this. Yeah, we can erase this equation. Then they're saying angle B is 90. We can see by the box here. And then angle, the side AB is 3. So AB's this side is 3 centimeter, and then the side BC, this side is how much? Is 4 centimeters. And then this is the information that is given. Now what do we have to do there? or identify the hypotenuse. So requiring the hypotenuse is the side opposite to 90. So meaning this will be our hypotenuse. And then the angle that is given, particularly angle theta in there. So in this case, doesn't matter. But if this was the angle, okay, they were given one angle here to reference. So it means against this angle here, theta, this will be the opposite. Let me write it in this way so that we can have our value of 3 invisible. So this is the opposite. Then it means this side underneath will be adjacent. So this is the adjacent side. Then now they say calculate the AC. What is AC? AC is our longest side from the triangle. So because this 90 degrees, or this right angle triangle, because of this 90, then we can use Pythagoras theorem to get the third side of saying hypotenuse squared equals to the opposite squared plus the adjacent squared. So they have applied that. What is our hypotenuse? Our hypotenuse in this case is AC. So they must have AC squared equals to, and then opposite here is given as AB. So we're going to say AB squared plus, and the adjacent is given as BC squared. Now if you check, this is what they have here. And of course you must write what is this. Where are you taking this? We take it from the Pythagoras theorem. So that's why it's important to write the reason, or where do we take this from, so that because it's a theorem, is proved with reasons. So if you code it, so you code where did we get this, right? The Pythagoras theorem. Then they substitute other side. So but here must still AC squared equals to 3, even if you don't put the units, fine, 3 squared plus 4 squared. So if you press a calculator, you're going to get what they done here. We're going to get AC squared equals to 9 plus 16. Our AC squared equals to, this is AC squared. AC squared equals to, and then this is 9 plus 6 is 25. Now from this 25, we are going to say AC equals to, now we bring in the square root of 25. So AC equals to 5 centimeters. So that's how they got the value of 5 here. So now we used Pythagoras theorem. Now we know that our hypotenuse there, we can replace it by putting a 5 centimeter there. Yeah, then that's what we have for the Pythagoras theorem. So let's continue with the second question. A second question from that example 1, which is 1.2 here. They're saying determine the values of the following trigonometric ratios. Now they're saying sine theta. Now already which one is the opposite, which one is the adjacent against this angle theta here. So let's see. So we said sine is opposite over. So the other way of getting, they're saying for sine we can have this, and then cos, and then tan. So having the first one, sine, we always have the opposite hypotenuse. The cos, we are having adjacent and the hypotenuse. Tan, we are having opposite and the adjacent. So what do we have here? Alright, first letter shows the trig function. Second letter is the numerator. The third letter is the denominator. So this can be written in the form of, we say sine is the trig function, and then O is the numerator, and H is the hypotenuse. So there will be equal sign between them, and then this will be the function of a certain angle. So we can do this for even the other remaining three here. So right, let's get back to this one. So now that's why they said sine of theta, the opposite there is AB, then the adjacent, the hypotenuse is AC. So it's given like this here. And then now the AB is 3, this one, and the BC, the AC, which is the hypotenuse, we got it as 5 units, or 5 centimeters. Then we replaced the whole of this ratio here. We replace the whole of this sine theta with this fraction. So can you see this thing, the relationship between the relationship between the angle and the sides. Right, let's get to number 2. We have cos theta here. Now on the cos theta, so they've defined this as BC, adjacent over hypotenuse. So let's look at that triangle again. So they defined as adjacent over hypotenuse. Adjacent is BC, it's given like this here. And then adjacent was given the number of centimeter, it was 4, and then hypotenuse is 5. We've calculated that. So that's how we get the trig ratios. And then it's fine. Let's get to the next example, or next activity 1.3. That's saying determine the size of angle A in terms of theta. So take note here, in terms of theta. So meaning in your answer, got answer is on theta. So what we've learned in log is that the angles of a triangle, or the sum of angles of a triangle, are either the angles in a triangle deal 3. So when they refer 108 degrees. So in triangle ABC, so running to add angle A plus angle B plus angle C plus angle C, they must give me 180 degrees. 180 degrees here. So here we in this case we know what we just have the three angles. We have theta, we know only 90, so we must get angle A in terms of 90. So let's substitute into this, or let's add them. So in that part, we are having, in that triangle ABC, we're having angle A plus angle B is 90 degrees plus angle C is theta equals to 180 degrees. Now we have to state the reason that angles in a triangle, or sum of angles in a triangle, to show that they give us 180 degrees. Now we must go and solve for A. Now how do you solve for A? So let me write it up there. Let me write it here. Then we're going to say angle A we're going to say angle A equals to 180 degrees my pen, 180 degrees minus, now we take the two group and say 90, or let's take them individually. So 90 it looks like sin f minus 90 degrees, and then theta has minus theta, then it means angle A, 180 and 90, they are just numbers, so do over 90 degrees minus theta, so that would be angle A. So that's how they've got our angle A here to be 90 minus theta degrees. So that would be angle A up there. So this will be angle A here. This will be 90 minus theta. Now let's look at the next problem. They said hence or otherwise determine the value of cos into 90 minus theta. So now look at this one, the interesting part. 90 minus theta, 90 minus theta, it will be 90 minus theta is the angle here. See the one I'm shading with red. So at red there point at the top, it will be 90 minus theta. So you don't have to work out this out. We simply know that where is our reference. Now if in that case let's write the opposite. Now the opposite side will now be this one, and now the adjacent side will be this side, because of that 90 minus alpha is there. So now let's write the function. So it means what we're going to have here, we're going to have what is the cos is the adjacent here over hypotenuse. What is the adjacent? Is AB, so it's written AB here. What is the hypotenuse? Is still AC. What do we have? We must have there is a mistake there. There must be AC. Our hypotenuse doesn't change, so we are going to have, this should be AB. My pen. This should be AB over AC. We have a problem here. So this is AB over AC. AB over AC, like that, not AB over BC. And then now this will be AB is 3 over AC is our 5 units. So this is what we have here. The answer was correct here, but the ratio there was not given correct. Right, that is our first example. So watch the next video on the basics of trigonometry before we take it to the Cartesian plane. So the next activity will be when we are taking it to the Cartesian plane, which is the revision of grade 10. Now we're taking the grade 9 work here, because here it's kind of grade 9 but it's combined with grade 10, because we are not yet on the Cartesian plane. But watch out for the next